Credible open source and media reporting indicates F-22 Raptors are being moved towards Iran. Open source tracking shows F-22 Raptors traveling from the U.S. toward bases in the Middle East. At least a dozen F-22s departed Langley Air Force Base heading east, likely via the UK transit route. While U.S. has deployed more than 50 advanced fighter jets to the region, Raptor is likely to be the tip of the spear in a possible move against Iran. In this video, Defense Updates analyzes why 12 F-22 Raptors can crush entire Iranian Air Force. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The Iranian Air Force, IRIAF, is structurally constrained service. Despite periodic modernization efforts and indigenous upgrades, it faces persistent limitations across platforms, sustainment, training, and networked warfare. These issues collectively affect readiness, survivability, and combat effectiveness in a high-intensity air campaign. The most visible challenge is the age profile of the IRIAF inventory. The Iranian Air Force fields more than 300 combat-capable aircraft, including roughly 190 fighters. The fleet comprises U.S. origin platforms such as the Northrop F-5, F-4 Phantom II, and Grumman F-14, alongside Russian-built types including the Sukhoi Su-22, Sukhoi Su-24, and MiG-29. Among these, the MiG-29 is the most modern fighter in service, with Iran operating only about 25 aircraft. Many airframes are decades old, creating structural fatigue concerns and increasing maintenance burden. Compounding the problem is fleet fragmentation. Iran operates multiple aircraft types from different countries and eras, each with distinct logistics chains, maintenance procedures, and spare parts requirements. This heterogeneity complicates sustainment planning, reduces economies of scale, and strains technical manpower. International sanctions have long restricted Iran's access to original equipment manufacturer, OEM support, particularly for Western platforms. As a result, the IRIAF relies heavily on cannibalization of grounded aircraft, reverse engineering, domestic refurbishment programs, and limited third-party procurement to sustain its fleet. While Iran has demonstrated notable ingenuity in keeping legacy aircraft airworthy, these workarounds typically cannot fully replicate factory-level reliability or comprehensive modernization pathways. Consequently, the force often experiences lower mission-capable rates and diminished sortie generation capacity during periods of sustained operational tempo. Even where airframes remain serviceable, avionics modernization has lagged behind contemporary standards. Many IRIAF fighters continue to operate with mechanically scanned radars, limited sensor fusion, older electronic warfare suites, and constrained beyond visual range (BVR) capability. Although indigenous upgrades have improved some platforms, the depth of integration and processing power generally trail modern 4th plus and 5th generation systems. This shortfall affects detection range, tracking quality, and resistance to electronic attack. In modern air combat, where information dominance is decisive, sensor and avionics gaps can be more consequential than raw aircraft numbers. Pilot proficiency is another major concern. High-end air combat effectiveness depends heavily on regular flying hours, advanced exercises, and exposure to complex multi-domain scenarios. Open-source assessments frequently suggest that IRIAF pilots receive fewer annual flight hours than their Western counterparts, largely due to maintenance constraints, budget pressures, airframe preservation concerns, and limited access to large force exercises. Iranian pilots are often regarded as skilled within their operating environment, but a reduced training tempo can affect readiness for high-intensity, network-centric warfare. Modern air power increasingly depends on integrated networks linking fighters, airborne early warning platforms, ground radars, and electronic warfare assets. While Iran has invested in improving its integrated air defense system, The overall battlespace networking architecture is generally assessed to be less mature than that of top-tier air forces. Key challenges include data link interoperability, real-time battlespace fusion, resilience under electronic attack, and distributed command and control. Without robust networking, even capable individual platforms cannot fully exploit their potential in contested airspace. The F-22 was purpose-built to dominate contested airspace. Unlike multi-role fighters that balance strike and air combat missions, the Raptor's primary function is to achieve and maintain air superiority. The F-22 Raptor's stealth profile is central to its combat dominance. Its shaping, radar-absorbent materials, and internal weapons carriage significantly reduce detection ranges against conventional radars, enabling the well-known first look, first shot, first kill advantage. In practice, an F-22 formation can detect adversary fighters at long range, track multiple targets simultaneously, and launch advanced air-to-air missiles before opponents are even aware of the threat. Iran's air defense network includes capable ground-based systems such as the Russian-origin S-300 PMU-2 and the indigenous Bavar 373. But their effectiveness against low-observable fifth-generation platforms is generally more limited, particularly without a fully integrated, modern sensor architecture comparable to peer competitors. As a result, even a small number of stealth fighters can generate disproportionate operational effects. One of the Raptor's most decisive advantages is its sensor fusion architecture. The AN/APG-77 AESA radar, electronic support measures, and other onboard sensors are fused into a single coherent tactical picture for the pilot, delivering exceptional situational awareness, passive detection capability, reduced cognitive workload, and enhanced multi-target engagement capacity. Many Iranian aircraft continue to rely on older mechanically scanned radars or less integrated avionics suites. Even where upgrades exist, they typically lack the seamless fusion that allows F-22 pilots to function as information-dominant nodes in the battlespace. In practical terms, a formation of 12 Raptors can operate as a tightly coordinated, networked hunting pack rather than as individual fighters. The F-22's ability to supercruise, sustain supersonic flight without afterburner, serves as another major force multiplier. Supercruise enables faster intercept timelines, higher missile launch energy, reduced infrared signature compared to afterburning fighters, and improved fuel efficiency at high speed. When combined with thrust vectoring and a high thrust-to-weight ratio, the Raptor maintains superior kinematic performance in both beyond visual range and within visual range combat. Most Iranian fighters cannot match this performance envelope. Even relatively capable platforms, such as the MiG-29, would face notable disadvantages in detection, missile employment range, and energy maneuverability when matched against the F-22. The Raptor typically carries advanced beyond visual range missiles internally, preserving stealth while maintaining lethality. Modern U.S. air-to-air missiles like AIM-120D features active radar homing, strong resistance to electronic countermeasures, networked mid-course updates, and high in-game maneuverability. Coupled with the F-22's sensor reach and low observability, these weapons enable engagements well outside the effective response envelope of many legacy fighters. A 12-aircraft F-22 package could prosecute a large number of aerial targets within a compressed time window, particularly when supported by airborne early warning and tanker assets. Finally, the Raptor is designed to operate as part of a broader networked combat ecosystem rather than as a standalone platform. Its effectiveness multiplies when integrated with airborne early warning aircraft, electronic warfare platforms, aerial refueling tankers, space-based ISR, and other fifth-generation fighters. Even if only 12 F-22s are counted as primary shooters, they would almost certainly function within this larger architecture. Such networked warfare compresses an adversary's decision cycle and complicates command and control. Viewers may note that Link 16 is being added to the Raptor fleet, and it is likely that the fighters selected for Iran mission will have it. With Link 16, military aircraft as well as ships and ground forces may exchange their tactical picture in near real time. Link 16 also supports the exchange of text messages, imagery data, and provides 2 channels of digital voice, 2.4 kilobits per second and or 16 kilobits per second in any combination. The presence of the F-22 Raptors in the region sends a clear message to Tehran. During last June's strikes, the stealth fighter was used to escort B-2 bombers over Iran. Raptor brings a lot more to the table compared to any fighter available to Iran in every aspect. It will brutally expose all the vulnerabilities Iranian Air Force has. A past incident shows what a Raptor can do. The incident happened in March 2013, when 2 Iranian F-4 Phantoms attempted to intercept an American MQ-1 Predator drone flying in international airspace. The drone was being escorted by 2 U.S. Air Force F-22 Raptors, which the Iranian pilots were completely unaware of due to the F-22's stealth capabilities. Kevin Showtime Sutterfield, piloting one of the F-22s, silently flew his aircraft directly underneath one of the Iranian F-4s to inspect its weapons load. After checking the armament, Sutterfield pulled up alongside the left wing of the Phantom. Then the F-22 pilot radioed the startled Iranian pilots and simply stated, "You really ought to go home." The Iranian pilots, realizing they were completely outclassed and had been tracked without their knowledge, immediately broke off their pursuit and returned to base. So, while Iranian military has many tricks up its sleeves, its air force is too weak to fend an attack by even a dozen F-22s.